continuing on with our operations, we just handled addition subtraction. We saw that was pretty simple. We just had to collect our like terms. Keep in mind with subtraction, you distribute and then collect like terms. Now we're going to tackle multiplying complex numbers. So we're going to throw over some properties of real numbers, such as distributive property. They're also valid for complex numbers. So we've already seen where we distributed the subtraction or through the complex number to do our subtraction. Now we're going to see where we can use our distributive property to multiply complex numbers. So basically what we're doing is we're going to be multiplying a binomial times another binomial, and that's what they look like. But one complex number times another complex number, and a lot of times what we do is we rely on this FOIL acronym to help us remember the double distributive property. So this is the double distributive property that says multiply your first terms, multiply your outermost terms, your innermost terms, and your last terms. So if we apply that, that's what we can do to help us figure out how to multiply. So that's our strategy for multiplying complex numbers. So we got 2 times 7, which is 14. Then we got 2 times a negative 4i, which is a negative 8i. You have a negative 3i times 7, which is a negative 21i. And then you have a negative 3i times a negative 4i, which is a positive, negative times negative is positive, 12i squared. Okay, so now we need to collect like terms and do some simplifying. The like terms that we have are sitting here are 2 i's. So we got 14 minus, and we're going to have 29i, then plus 12i squared. Well, the I squared, if you got to remember that I squared is equivalent to a negative 1, so really it's plus 12 times a negative 1, or it's 14 minus 29i minus 12, and you can collect like terms again, and it's going to equal, I'm going to go this direction, 2 minus 29i. So this is our complex number in standard form. Don't forget to put them in standard form. In standard form, you should never have anything more than a real part and then your imaginary part, where a and b are real, and I is always by itself. Okay. We'll look at one more example of multiplying complex numbers. If you don't recognize it, I'm going to point this out to you in the next one. We're multiplying numbers that are conjugates. The term conjugate means they're exactly the same except for the sign in the middle. It's like the difference of 2 perfect squares, that factorization, but you're going to see something interesting happen when you actually multiply these out. So the first terms, 4 times 4, our outermost is a negative 20i, the innermost is plus 20i, and your last is going to be minus 25i squared. Now, every time you multiply conjugates together, these middle terms are going to cancel. I call them the o's, the o and the I. The o's will reduce, they'll simplify to an equivalency of 0, so it's going to be 16 minus 25i squared, and I squared is a negative 1, so it's going to be really just 16 plus 25. 25, 35, it's a value of 41 plus 0i. Now, when you don't have any imaginary part, it's okay to write it as just 41. That's still a complex number in standard form. So multiplication of complex numbers is nothing more than utilizing your double distributive property or FOIL.